Hello, welcome back to Decaf-Math, and welcome if you are new here. Today, let's go over the product rule, which applies to derivatives, which are introduced in calculus. So, thank you for those of you who have reached out and requested this topic kindly. And I hope that this is helpful and, if nothing else, relaxing. So, before we start, I did want to mention that even if you aren't taking calculus, or maybe you are taking calculus now and are struggling with it, or maybe you took calculus at some point in your life but it's all long forgotten, or you never even really needed to learn calculus, so you never did. Wherever you are and whatever your relationship with math looks like, I'm just thankful that week after week we come together here in this moment, and that I hope that beyond just the math, that this space and this channel can be or continue to be a peaceful space for you, and hopefully you're enjoying it as much as I am. I know that I definitely very much appreciate being able to just step aside for a little while and not worry about deadlines or making mistakes or anything really. Giving up that control and having this space to be however we are is such a blessing. So, if you're still with me here now at this moment, thank you for just being you, and thank you for being here. So follow along with however much you think is helpful. Maybe you need a good night's sleep and this is boring enough for you to just drift off. So if that's the case, you are more than welcome to. And if you need some help with actual practice problems, I hope that this is helpful, and you are more than welcome to reach out if you want to see more. And of course, feel free to browse around my ever-growing math topics, the playlists. Okay, anyways, the product rule applies for derivatives, like we said, and basically it tells us what to do when we are multiplying two functions. So first of all, it's important that by now we know what functions are, and I'll try to remember to link my other videos on functions, and we will study them more, of course, as we fill in more topics. But if we have f of x, so some sort of thing to do with just x, okay, some function of x, so, x plus 1, 2x squared, you might have an e to the x, you might have an ln x, you might have some trigonometric function, whatever the case may be. If we have f of x times g of x, so another function, and we're multiplying them together, hence the product, and we were to take the derivative, so either you can write that as this with a little prime, or you can just write d of f of x times g of x dx. Okay, and you can squish them together, so fx gx. Okay, this product rule tells us what to do when we find the derivative of this. So it might just be easier to see an actual example first, or just like what this might look like. So you might have something like e to the x sine x, okay, like that. And the question is to find the derivative, okay? So of course, you'll need to kind of translate this notation into whatever your problem is, because, you know, for instance, your problem might just say f of x equals this thing, and then what is the derivative of that f of x? But you'll notice that this is a product of two functions. So yeah, as you get more practice, you'll get the hang of how this works. But the tempting thing to do here is, when we try to find the derivative, is to try to take the derivative of this first part and take the derivative of the second part and just multiply. And if only it were just that simple. It's so tempting because it's stuff times stuff prime. But it's a little bit more complicated than that, and that's where this rule comes in. Okay? And once you get the hang of it, it's not so bad, but at first it might be a little bit intimidating, okay? So let me just write it out. If I have two functions that are multiplied together, the derivative of that is f of x, so you keep the first function, times the derivative of the second, okay, plus the derivative of the first function, times, and then just the second, okay? So keep this, prime this, plus prime this, keep this. That whole thing together, this whole thing is the derivative of the product. So that is the product rule. That's it. So now it's a matter of, when you calculate this, know what your f is, know what your g is. And then when it comes time to taking the derivatives, hopefully you'll remember your derivative rules and be able to calculate, for instance, the derivative of the second one, and then you just multiply the first part, and then plus, and then hopefully you'll know how to find the derivative of this first function, times, and then you just keep this as is. That's it. Okay, so I say it like that's so simple, but don't worry, let's just give it a try. So I could probably make so many more videos with tons and tons of practice problems, and we will, but for right now we're just kind of laying down the foundation, and then in the future we can just jump straight in, okay? So let's just try this example, just because I kind of just came to me, so why not this? So let's say I'm trying to find the derivative of this. So first thing, I'll need to remember that, well, first I need to notice that I'm multiplying two functions of x. Basically just stuff with x, and they're multiplied. So this first thing is my f of x, and let's see, maybe we can do another color. This thing is g of x. Okay, so then writing it out, I have f of x, so I'm keeping this exactly as is. Okay, I have f of x, so that's e to the x, times the derivative g of x, my second function. So sine of x prime, and we'll come back to that, plus f prime of x, so e to the x prime, times g of x, which is just keeping the function as is. Okay? And of course I didn't really mention, but I think it's kind of assumed that f of x and g of x are differentiable. Okay, so that the derivatives actually exist. Okay, so literally breaking it down into this form, and now we just look at what we have. And so if taking derivatives or basic derivatives is fresh in your mind, hopefully we'll be able to recognize these and simplify. So I'll keep the e to the x, and then this is where we might need to kind of dig into our memories, but hopefully if you're taking calculus and you are at this point that you are coming fresh from memorizing or studying your basic derivatives. But this is a trig function, and the derivative of sine of x is cosine of x. Okay, and then plus the derivative of e to the x. E to the x is e to the x. Okay, so this just becomes this. The derivative of sine x becomes cosine x, and then times sine x. So I hope that this is comfortable for you, and that the derivative of sine of x is cosine of x. I hope that's comfortable. But if not, take your time. Just know that at this point, these two parts, just taking the derivatives, are based on memorizing and knowing your basic derivatives, and that the product rule kind of builds on that. Okay, so from there we just have, so I'm just going to combine it now, just kind of rewrite it, e to the x cosine x plus e to the x sine x. And if you want, you can see that you have an e to the x here and e to the x here. Just to simplify, you can just factor it. And that's it. That is the derivative of e to the x sine x. Okay? Alright, so it's a little bit more complicated. See, if we were to just do what we would kind of naturally or might naturally think, if you were to do e to the x prime times sine x prime, you'd get e to the x cosine x, which is only that first part. It's just this part, but we should have this other part too. So this would be a sad day. No, it's totally okay. It is a very common mistake, but hopefully now that we mention it here, it's not as tempting. And pointing these things out is what I'm here for. Okay, so let's give another one a try. Let's try x squared plus, 3x, kind of trying to make up one, 7x minus 2. Okay, so you might not have things written directly for you as f and g. It might not be written exactly with those letters. Okay, so try to generalize this as a concept. Okay, so for instance, I might ask you, I might say f of x equals this. What is f prime of x? Okay, And so here you would notice that this f of x is not the f of x in this rule, right? When we find the derivative of this product, you're really just, in this case, finding f prime of x. So we're doing x squared plus 3x times 7x minus 2 prime. Okay? So, one thing I would point out here is it's very possible, in fact it might even be easier depending, but you can FOIL this out to get a polynomial. Okay, so you could do x squared times 7x is 7x cubed minus 2x squared plus 21x squared, and combine those, and then a negative 6x. And then take the derivative of each piece and combine, okay, like you normally would for polynomials, okay? So that's just based on our rule that, you know, x to the n, this is our power rule. The power rule is nx to the n minus 1. And then combining that with the fact that we can pull out constant coefficients leads us to be able to sort of combine those rules and also sort of distribute the derivative when you have a sum, so adding or subtracting. The combination of all of that, those are just properties of the derivative, and also, you know, which really comes from the property of a limit. That just means that we can find the derivative just normally of, you know, polynomials. So, you know, like stuff like this, right? We can just take the derivative of each part. So I wanted to point that out because for this question, we could do that. We can FOIL this out, first, outer, inner, last, combine whatever we can combine, and then just take the derivative as we would. But let's see if we get the same thing by using the product rule, because technically we can. This is a function of x, so stuff with x times another function of x, and we're taking the derivative. So now let's just apply the rule. So, you know, in this case I'm not going to write f and g anymore because that's going to get confusing with the way that the question is worded, but you know, sometimes teachers write this, so I wanted to point it out. So we're going to focus on the concept. So basically, I keep this first thing, so that's my f of x, right, this first one, and then I take the derivative of the second one, and then I add the derivative of the first one, and then I multiply that by just keeping the second. And as you get more and more practice with this, you won't even need to write this out. You'll just be able to do the derivative in your head. So let's just keep going before I, you know, go off on a tangent. Haha, tangent. So we have x squared plus 3x times, and then the derivative of 7x minus 2 is just 7. The 2 prime becomes 0, goes away, right? So it's just 7 plus, and then the derivative of x squared plus 3x is the derivative of x squared, which is 2x plus 3 times 7x minus 2. And here we just have to work out the algebra. So this is a 7, so I'm just going to go ahead and distribute that. So 7x squared plus 21x plus, and then FOIL this out, first, outer, inner, and last. So 14x squared minus 4x plus 21x minus 6. And then we combine our like terms. So 7x squared plus 14x squared is 21x squared. And then I have a 21x minus 4x, yikes, 17x plus 21x is 38, is that right, 38, plus 38x, and then a minus 6. So that is our answer. We can actually, oops, sorry about that. I just really simplified this by combining like terms. But we can actually check this answer by multiplying this out. So let's see if we get the same thing, okay? Just really quickly. So, droop. Just gonna multiply it out quickly to see if we got the right answer here. But let's see, so we have x squared plus 3x times 7x minus 2. So I'll just go ahead and FOIL that. So we have 7x cubed minus 2x squared plus 21x squared minus 6x. So that's 7x cubed plus 19x squared minus 6x. So then when I take the derivative of that, so this is f of x. So this is f of x. So then f prime is, and this is where we can take the derivative of this, plus the derivative of this, minus the derivative of that. And we can pull out the coefficients. So we have 21x squared plus 2 times 19 is 38x, and then a minus 6. And that does look just exactly like what we got. So in this particular case, I think it's pretty much the same amount of work, and especially as you get more and more comfortable with using this rule, you'll be able to do the derivative parts right in your head, and it'll just be about doing the algebra. So whether you want to do that algebra in the beginning for these polynomial types and then take the derivative, or the other way around, it doesn't really matter. But I just wanted to show you that it's possible to do it both ways. But for one like this, this e to the x sine x, there really isn't much more you can do. Okay, I think I'm just going to leave it now. But from there, we can do more practice problems. So at this point, hopefully you feel pretty comfortable with trig functions, polynomials, so finding derivatives, polynomials via power rule. I would say e to the x and ln x, which I will make a video on its own, probably, maybe even just a really sleepy video, but these two are pretty straightforward to just memorize. And the chain rule. So we're going to have lots of fun with this, but when it comes to the product rule, of course, this is just a general pattern, okay? So we're going to get used to keeping the first, multiplying by the derivative of the second, plus the derivative of the first, keep the second. So this, d this, plus d this, this. Once you do it over and over again, it'll just really become second nature. But remember that when you do write this out, the derivative of the second part and the derivative of the first part might contain something where you need to apply another rule. So you might need to use the chain rule to find the derivative of this. So something like, I don't know if I can come up with a good example right off the top of my head, but like x squared times sine of 3x plus 5 or something like that. Okay, so we keep this and take the derivative of this plus the derivative of this times keeping this. But when it comes time to taking the derivative of this thing, we can't just forget about our other rules. So just keep that in mind as you're doing practice problems and as you learn other rules for derivatives. We have to just kind of take it step by step. So I hope that this was kind of a helpful intro, and in the future we'll just jump straight in. I know it's kind of rambly, kind of intentionally so. Just wanted to chill, just wanted to introduce the idea. So I will see you around soon, and if you are asleep by now, sweet, sweet, sweet dreams, and I hope that you have a wonderful day or night or afternoon, wherever you are. Sending you all my love. Bye.